Hello friends, welcome to Get My Job channel. In today's video, we'll see top 10 questions for cracking electrical engineer job interview on hazardous area classification. So friends, prepare for the interview for the job of electrical engineer. Let us know the top questions on hazardous area classification which are asked during the electrical engineering job interview. To support your interview preparation, I'll be publishing series of such videos on each aspect of electrical. To get such videos first hand, please subscribe my channel and press the bell icon. So friends, what is hazardous area classification? When electrical equipment is used in, around or near an atmosphere that has flammable gases or vapors, flammable liquids, combustible dust, ignitable fibers or flyings, there is always a possibility or risk that a fire or explosion might occur. Those areas where the possibility or risk of fire or explosion might occur due to an explosive atmosphere and or mixture is often called a hazardous location or area. Currently, there are two systems used to classify these hazardous area: the class or division system and the zone system. The class or division system is used predominantly in the United States of America and Canada, whereas the rest of the world generally uses the zone system. However, the United States and Canada are trending more towards the zone system. What is class system for the hazardous area classification? The class defines the general nature or properties of hazardous material in the surrounding atmosphere, which may or may not be in sufficient quantities. Class 1: location in which flammable gases or vapors may or may not be in sufficient quantities to produce explosive or ignitable mixtures. Class 2: location in which combustible dust, either in suspension, intermittently or periodically, may or may not be in sufficient quantities to produce explosive or ignitable mixtures. Class 3: location in which ignitable fibers may or may not be in sufficient quantities to produce explosive or ignitable mixtures. What is division system for the hazardous area classification? Division. The division defines the probability of hazardous material being able to produce an explosive or ignitable mixture based upon its presence. Division 1 indicates that the hazardous material has a high probability of producing an explosive or ignitable mixture due to it being present continuously, intermittently or periodically, or from the equipment itself under normal operating conditions. Division 2 indicates that the hazardous material has a low probability of producing an explosive or ignitable mixture and is present only during abnormal conditions for a short period of time. What is group system for hazardous area classification? The group defines the type of hazardous material in the surrounding atmosphere. Groups A, B, C and D are for the gases, while groups E, F and G are for the dust and flying. So group A, atmosphere containing acetylene. Group B contains atmosphere containing an flammable gas, flammable liquid produced vapor or combustible liquid produced vapor whose MESG is less than 0.45 mm or MIC ratio is less than 0.40. Typical gases include hydrogen, butadiene, ethylene oxide, propylene oxide and acrolein. Group C, atmosphere containing a flammable gas, flammable liquid produced vapor or combustible liquid produced vapor whose MESG is greater than 0.45 mm but less than or equal to 0.75 mm, or MIC ratio is greater than 0.40 but less than or equal to 0.8. Typical gases include ethyl ether, ethylene, acetaldehyde and cyclopropane. Group D, atmosphere containing a flammable gas, flammable liquid produce vapor or combustible liquid produce vapor whose MESG is greater than 0.75 mm or MIC ratio is greater than 0.8. Typical gases include acetone, ammonia, benzene, butane, ethanol, gasoline, methane, natural gas, naphtha and propane. Group E, atmosphere containing combustible metal dust such as aluminum, magnesium and their commercial alloys. Group F, atmosphere containing combustible carbonous dust with 8% or more trapped volatiles such as carbon black, coal or coke dust. Group G, atmospheres containing combustible dust not included in the group E or group F. Typical dust include flour, starch, grain, wood plastics and the chemicals. What is zone system for hazardous area classification? Hazardous locations per the zone system are classified according to its zone, which can be gas or dust. For gas atmospheres, electrical equipment is further divided into groups and subgroups. Zone. The zone defines the probability of hazardous material, gas or dust being present in sufficient quantities to produce explosive or ignitable mixtures. Gas. Zone 0. Ignitable concentrations of flammable gases or vapors which are present continuously or for long period of time. Zone 1. Ignitable concentration of flammable gases or vapors which are likely to occur under normal operating condition. Zone 2. Ignitable concentration of flammable gases or vapor which are not likely to occur under normal operating condition and do so only for a short period of time. Dust. Zone 20. An area where combustible dust or ignitable fibers and flies are present continuously or for the long periods of time. Zone 21. An area where combustible dust or ignitable fibers and flies are likely to occur under normal operating conditions. Zone 22. An area where combustible dust or ignitable fibers and flies are not likely to occur under normal operating conditions and do so only for a short period of time. What is group classification for hazardous area? Group. Electrical equipment is divided into three groups. Group 1. Equipment intended in use in mines susceptible to fire, damp, flammable mixture of gases naturally occurring in a mine. Group 2. Equipment intended in use in places with an explosive gas atmosphere other than mines susceptible to fire damp. Group 2 equipment is subdivided into three categories. Group 2A, atmosphere containing propane or gases and vapors of equivalent hazard. Group 2B, atmosphere containing ethylene or gases and vapors of equivalent hazard. Group 2C, atmosphere containing acetylene or hydrogen or gases in vapors of equivalent hazard. Group 3, equipment intended in use in places with an explosive dust atmosphere. Group 3 equivalent equipment is subdivided into three subgroups. Group 3A, atmosphere containing combustible flies. Group 3B, atmosphere containing non-conductive dust. Group 3C, atmospheres containing conductive dust. What are different protection techniques and methods under class or division systems? Explosion proof, a type of protection that utilizes an enclosure that is capable of withstanding an explosive gas or vapor within it or preventing the ignition of an explosive gas or vapor that may surround it and that operates at such an external temperature that a surrounding explosive gas or vapor will not be ignited thereby. Intrinsically safe, a type of protection in which electrical equipment under normal or abnormal condition is incapable of releasing sufficient electrical or thermal energy to cause ignition of specific hazardous hazardous atmosphere mixture in its most easily ignitable concentration. Dust ignition proof, a type of protection that excludes ignitable amounts of dust or amounts that might affect performance or rating, and that when installed and protected in accordance with the original design intent will not allow arc, spark or heat otherwise generated or liberated inside the exposure to cause ignition of exterior accumulations or atmospheric suspension of a specified dust. Non-incendive, a type of protection in which equipment is incapable under normal condition of causing ignition of a specified flammable gas or vapor in air mixture due to arcing or thermal effect. What are different protection techniques and methods used under zone system? The below concept are high level protection concept. There are also sub levels of protection that may or may not be applicable to each type. Also, some protection equipment may combine multiple types of protection. Flame proof, a type of protection in which an explosive can withstand the pressure developed during an internal explosion of an explosive mixture and that prevents the transmission of explosion to the explosive atmosphere surrounding the enclosure, and that operates at such an external temperature that a surrounding explosive gas or vapor will not be ignited there. This type of protection is referred as EXD, intrinsically safe, a type of protection in which the electrical equipment under normal or abnormal condition is incapable of releasing sufficient electrical or thermal energy to cause ignition or a specific hazardous atmospheric mixture in its most easily ignitable concentration. This type of protection is referred as EXI. Increased safety, a type of protection in which various measures are applied to reduce the probability of excessive temperatures and occurrence of arcs or spark in the interior and on the external parts of electrical apparatus that do not produce them in normal service. Increased safety may be used with flame-proof type of protection. This type of protection is referred as EXE. Type N, a type of protection applied to electrical equipment such that in normal operation it is not capable of igniting a surrounding explosive atmosphere. This type of protection is referred as EXN. Type T, a protection in which electrical equipment is equipped with an enclosure providing dust ingress protection and a means to limit surface temperature. This type of protection is referred as EXT. Type H refers to one of the three different types of protection, where constructional measures are applied to protect against the possibility of ignition from hot surfaces, spark, and compression generated by the moving parts. Ignition protection, where mechanical or electrical devices are used in conjunction with non-electrical equipment to manually or automatically reduce the likelihood of a potential ignition source from becoming an effective ignition source. Protection, where potential ignition sources are made ineffective or separated from the explosive atmosphere by either totally immersing them in a protective liquid or by partially immersing with continuously coating their active surfaces with a protective liquid in such a way that an explosive atmosphere which may be above the liquid or outside the equipment enclosure cannot be ignited. Non-electrical equipment often apply EXH protection methods. What is the temperature protection for hazardous area classification system? A mixture of hazardous gases and air may be ignited by coming into contact with a hot surface. The condition under which a hot surface will ignite a gas depends on the surface area, temperature, and the concentration of the gas. The same can be said about the combustible dust. The T code of a product denotes the maximum surface temperature that a given product will not exceed under specified ambient temperature. For example, a product with T code T3 means its maximum surface temperature will not exceed 200 degrees centigrade, provided it is operated in an ambient temperature defined by the manufacturer. So T1 surface temperature is 450 degrees centigrade, T2 300 degrees centigrade, T3 200 degrees centigrade, T4 135 degrees centigrade, T5 100 degrees centigrade, T6 85 degrees centigrade. Which are the different approval agencies? Generally speaking, most countries require that products intended for installation in a hazardous location are approved by a recognized authority or approval agency, governmental or independent, which that country has established by various laws, regulation and codes. The typical agencies are FM. FM is factory manual. Is approval accepted in North America. CML, Certification Management Limited. This agency is accepted in Japan. CSA, Canadian Standards Association, North America. ATEX, BASIFA, British Approval Service for Electrical Equipment in Flammable Atmosphere. KEMA, NV taught Kyung Van Electrotechnic Materialen, LCIE, Laboratories Central Des Industries Electrics. This is accepted in European Union. IECEX, CSA, Canadian Standard Association, and BASIFA, British Approval Service for Electrical Equipment in Flammable Atmosphere. This is accepted internationally. SAA, Standard Association of Australia. This is accepted in Australia. NEPSI, National Supervision and Inspection Center for Explosive Protection Safety of Instrumentation. This is accepted in China. TINS, Technology Institute of Industrial Safety. This is accepted in Japan. INMETRO, National Institute of Metrology, Quality and Technology. This is accepted in Brazil. CUTR, FGUP Certification Center, certification body. This is accepted in Russia, Belarus, Kazakhstan and America. So friends, I hope this information was useful for you and you will take advantage of it. Please like and subscribe my YouTube channel for more such videos. Thank you friends.